Hello everyone. Here is the question. When 50 ml of 0.1 molar ammonium hydroxide is mixed with 25 ml of 0.1 molar HCl, then pH of the resulting mixture is, the given int is, the only pKb value it is given, and that is 4.74 it is. So what are we supposed to do in order to solve this question is, when the mixture it is given, is there any chemical reaction is occurring? So you try to see the reaction in between the ammonium hydroxide, that is NH₄OH, and HCl. And we know that one acid and base, if it is combined, it ends up the neutralization reaction. You will be getting ammonium chloride NH4Cl plus, from here if you observe, we will be taking the water. So from here plus water it will be comes out. This, it is the reaction in between the weak base and strong acid that you have. So the final salt it is formed here, it is acidic salt. So then what we are supposed to do is, if we'll try to calculate the number of moles in it. So number of moles if you wanted to calculate, so generally what will have molarity, it is equals to number of moles by volume. So number of moles if you wanted to calculate, you will be taking the molarity into volume. So volume here you can consider in terms of the liters. So what are we supposed to do is, we'll just try to apply the same thing. So number of moles with respect to base data, it is given how much molarity, it is 0.1 into the volume here it is given how much, 50 ml. So 50, the whole you will be having by 1000, or else directly also you can do, and that value whenever that you are calculating, it will be comes out as 0.1 directly. If I substitute into 0.05 you will have. So this is what, so the final value how much you will get, you will end up getting this 0.005. so this is, so these many number of moles of base. So here if you are calculating, so here you will have with respect to acid, you have 0.1 into volume, here it is given 25, and by 1000 if you are doing the total value, it will be comes out as 0.0025 moles. So these many moles it will be consumed. So here if you clearly observe, the limiting reagent is going to be HCl, because it is less number of moles. So for each mole of HCl, only 1 mole of the ammonium hydroxide is required. Hence 0.0025 moles of this requires the same. So from here again 0.0025 moles it will be left. Okay, so these many moles it will be left in the solution itself. So now the solution it will be having, for example, this is what mixture if you are having, then you will have two things. So one salt you will have, that is acidic salt, plus base also you will have. So that base it is weak base. So indirectly this is going to be the basic buffer. So basic buffer indirectly. So here one base you will have. So along with this, the basic the base with the strong acid, that salt it will be having. So that is called as a basic buffer. So what is the formula you will have in order to calculate this is pOH you have to calculate. So pOH is equals to pKb plus log of concentration with respect to salt by concentration of base you will have. Okay, so then from here if you are calculating pKb, it is given already, so that's going to be 4.74 plus log of concentration of both of them. Concentration only the equal moles it will be reacts, so that's going to be 0.0025 by concentration of this base also 0.0025. okay, so then here these two values it will be getting cancelled, and that's going to be log 1. So log 1 it is gets nullified, that is 4.74 you will have pOH. So then what's our job is, pH we have to calculate. So we know this relation pH plus pOH is going to be 14. So now pH, if you wanted to calculate, it will be equals to 14 minus pOH. So pOH value, it is how much? 14 minus 4.74. So the value here you will end up getting is 9.26. So this is the final value. So pH of the basic buffer, whatever we have, it is this.